Hello. In question 3, we're going to be doing some matrix math. For part 1, we need to calculate this. So, let's just get started. Y transpose, as stated. So Y is this, so we need to transpose it. So the transpose of this is going to be when we flip it onto its side. So we're going to get 1, 1, 0. This is the first row of Y. The second row of Y is 1, 0, 1. And the third row is 0, negative 1, 0. This is Y transpose. Now this is multiplied by the Hadamard product of X and Y. So this is going to be 1, 0, 1 times 0, 1, 1. And that's just going to be, you multiply them straight across. So in this case, it would just be like this, that, and that. So we're going to get 0, 0, 1. And this is added to the inner product of x and y, which is equivalent to the dot product because x and y are vectors. So we're going to do our normal dot product method. I like to do it like this. This is x and this is y, and I sort of collapse them onto their side like that, and that gives me 1 times 0 plus 0 times 1 plus 1 times 1. This is just, nope, this is 1. So what we're going to do is we're going to multiply these out. This looks a little bit messy. This is multiplied implied dot product here, because if there's no operation, we just assume dot product. 0, 0, 1, which is the result of the Hadamard product. And then we add on 1. So now we're going to do our dot product here. Let me give myself a little bit more space. 1, 1, 0, 1, 0, 1, 0, 1, 0 times, oh nope, let's do it like this. So then if I collapse these onto their side for every row, I can get 0. This will give me negative 1, and this will give me 0. Then we add on our scalar, and our scalar is just a matrix of 1s. So we get 1, 0, 1. That's our answer for part 1. Part 2 is y, the inner product of y and y plus I. So we're going to do y, y, I. So y is equivalent to, I believe, 0, 1, 1. And we're going to do the inner product, so this is the same as dot producting. Oh, no, this is the outer product, never mind. So this is going to equal 0 times 0, 1, 1, 1 times 1, 1 times. So the second matrix is multiplied by every entry in the first matrix in the outer product. This is going to give us, I believe, 0, 0, 0, 0, 1, 1, 0, 1, 1. Cool. Now we need to add the identity matrix. The identity matrix, in this case, is always going to be a column, or sorry, a diagonal of zeros and it should be a square matrix. And so we want to match dimensions, so this is going to be technically I3. We just add the elements up, and we get 1, 0, 0, 0, 2, 1, 0, 0, sorry, 0, 1, 2. That is our answer for part 2. For part 3, we have the inner product of z and z. Z is this, so I'm going to copy that down. 0, negative 1, 0, and 1, 0, 0. I'm going to make that a bit cleaner. Now, you might remember that the inner product of two matrices, so let's just see this out in clear here. Z is equivalent to the trace of Z transpose. So what we're going to do, oh, this is the wrong notation. Yeah, whatever. So we're going to do this. And we get negative 1 squared here, which is just 1. And we get 0, 0, and this should be 1. So we get, really, this is just I2. So the trace of I2, this is the identity matrix of the second dimension. This is equivalent to 1 plus 1, because the trace is the sum of all the elements on the diagonal, which is just 2. So that's our answer for part 3. Now for part 4, the x, y, z transpose. So let me just record these. X is 1, 1, 0, 0, 2, 0, 0, 0, 1. 1, 1, 0, 0, 2, 0, 0, 0, 1. Y is 1, 1, 0, 1, 0, 1, 0, negative 1, 0. Z transpose, right? Yeah, Z transpose. We have it up here, so it's just 0, negative 1, 0, 1, 0, 0. And now we just multiply these out. So if I just put I can get the dot product by using my normal trick. So I just, again, collapse, kind of flip it sideways in my head. And this will give us 2. This is 1, and this is 1. This is going to give 2, 0, 2, and 0, negative 1, 0. No, this is 1. Did I copy x wrongly? I did copy x wrongly. X is this, which means this is certainly 0. This is still negative 1, and that is 0. And now that we're in the perfect form for me to do my another collapsing trick, so this is just x, y, and this is z transpose, and we're just going to multiply them out again with another dot product. This is going to be 2 by 3 So we're going to get for our first entry, -1. It's going to be 2. We're going to get 0, 2, 1, 0. And that is our answer for part 4. That is the entirety of question 2.